Number 11. The value V pounds of a mobile phone t months after it was bought is modeled by V is equal to AB to the power t, where A and B are constants. Figure 2 shows the linear relationship between log 10V and t. The line passes through the points 0, 3, 10, 2.79 as shown. Using these points, part A, find the initial value of the phone. So for part A, the initial value of the phone is going to be where t is equal to 0, and we can see that that is when it is equal to 3. So log V is equal to 3, and because we are looking for the value, we would then do V is equal to 10 to the power 3, and that gives us £1,000. Part B says, find a complete equation for V in terms of t, giving the exact value of A and giving the value of B to 3 significant figures. In the diagram, we can see that this is a straight line graph, and the equation that we have is V is equal to AB to the power t. The equation of a straight line graph is Y is equal to mx plus c. If we substitute the Y value with what's shown on the graph, which is log 10V, and the x value with what's shown on the graph, which is t, this is what the equation should look like. We can also find the gradient m of the equation by using the 2 points that we've been given, by doing the change in y divided by the change in x. So if we did 2.79 take away 3 over 10 take away 0, that would give negative 0.021. So we've now got the gradient of the graph, and we can see that the y-intercept is 3. So if we were to write these values into the equation of the graph, we would write this as log 10v is equal to minus 0.021t plus the y-intercept, which is 3. So we've now got the equation of the line graph, and in order to find A and B, we would first have to write it in the form v is equal to 10 to the power minus 0.021t plus 3. We know that when we are adding the exponents, that means we have multiplied the two base numbers, so we can rewrite this as v is equal to 10 to the power 3 multiplied by 10 to the power minus 0.021t. 10 to the power 3 gives us 1,000, and for 10 to the power minus 0.021t, we can again rewrite this as 10 to the power minus 0.021, close the bracket and put the t as a power outside the bracket. We now have this in the exact form that the initial equation v is equal to ab to the power t was given. The question says to give the exact value of a, so we have found that as 1,000. And the question says to give the value of b to 3 significant figures. So on the calculator, if we work out 10 to the power minus 0.021, that would give us an answer of 0.953. So we now have an equation in terms of v and t, and we have also found the values of a and b. The question then says, exactly 2 years after it was bought, the value of the phone was 320. Use this information to evaluate the reliability of the model. Because we've been given the value exactly after 2 years, and the question is giving us t in terms of months, we would therefore have to convert the 2 years into months, which would equate to 24 months. If we then use the equation that we found in part B and substitute t as 24 and put that into the calculator, this would give us the value of v as £315. And therefore, we can say that this model seems to be reliable because £315 is very close to £320.